Alright guys, so today we're going to go over the Unit 2 DCA test review. This is going to be problems 1 through 8. Please see part 2 of this video to see 9 through 15. So let's get started on number 1. It wants us to solve for y. What this means is to actually solve for the solution of y, not solve the equations into slope-intercept form. So since this equation right here is x equals y plus 2, I'm just going to go ahead and solve this via substitution. Plug this in for x right here. And so when I rewrite this equation, instead of writing x, I'm going to write y plus 2, and then plus y equals negative 8. And I'm going to combine my y's together, so I get 2y plus 2 equals negative 8. And now I can start solving for y. So I'm going to subtract 2. And I get 2y is equal to negative 8 minus 2 is negative 10. Divide by 2. And we get y equals negative 5. And since I'm solving for y, this is my final answer. You could have solved this also in a couple other different ways. I found substitution to be the easiest. Looking at number 2, it says the following matrix represents a system of linear equations in x, y, and z, and it asks us to solve. So since it already gives us this matrix, we can go ahead and plug it into our calculator. So what I'm going to do is I'm going to hit the second, go to x equals negative, or x to the negative 1. You want option B for RREF to plug in my matrix alpha zoom. And this matrix has 3 rows and 4 columns, so we're going to make it a 3 by 4. And I'm going to start plugging in my numbers. So 1, 0, negative 5, 8, 1, 0, and 7. 1, and that is a negative 4. I'm going to go ahead and solve. And that gets us x equals negative 12, y is equal to 7, and z is equal to negative 4. Because again, it's always x, y, and z, x, y, and z. Alright, let's take a look at number 3. So the student has 45 coins in her pocket that have a value of $3.85. The coins are either nickels or dimes. Write a system of linear equations to represent this scenario. So before I do anything else, I need to define my variables. In this case, that is nickels and dimes. I'm going to say nickels is N and dimes is D. You are more than welcome to use X and Y as well, and you could replace N and D. So I know that I have a total of 45 coins, so if I were to take my nickels and my dimes and add them together, I would have a total of 45 nickels and dimes, okay? And then it says those coins have a value of $3.85. So I know that I have a total of $3.85. Now a nickel is worth 5 cents, so to write that in terms of a decimal, that would be 0.05 because it is 0.05 of a dollar. So this is going to be 0.05 times the number of nickels I have, plus, and then dimes. A dime is worth 10 cents, so that is worth 0.10 of a dollar. So 0.10 times D. So 0.05N plus 0.10D equals our $3.85. And this is our final answer because it just wants the system of equations. We don't have to go further. Moving on to number 4. Your friend wants to solve this system using elimination. And he gives us this system right here of 3x minus 4y equals 1 and 5x plus 2y equals 7. Now, before I look at the answer choices, we're going to evaluate this ourselves. In order to eliminate a variable when we combine equations. The variable needs to have coefficients that are the same number but opposite sign. So looking at my x's, they are not the same number and they are both positive. Versus my y values, the 4 is this negative, this 4y is negative, but the 2y is positive. So this one is easier to eliminate. All I would have to do is make this 4, and to get 2y to become 4y, we would simply multiply it by a positive 2. Because again, we like the signs the way they are, we just need this 2y to become 4y. Now, looking at my answer choices. Letter F tells us to multiply the top equation by -1. That doesn't work. G wants us to multiply the bottom equation by -2. We had +2, so that doesn't work. H tells you to multiply the top equation by -5. Nope, that's nowhere close. And then J says to multiply the bottom equation by 2, which is what we did, so J is our answer. All right, let's scroll back up to number 5. It says the perimeter of a rectangular garden is 327 feet. The length is 10 feet more than 3 times the width. What is the system of equations used to find the length and width of the garden? And it tells us let L be the length and W be the width. Now my L's and my 1's tend to look the same, so what I usually do when I write this is I use this as an L. I use a cursive L, but you are welcome to do what you wish. Now I know that perimeter is when I add all of the sides together. On a rectangular garden, or on a rectangle, that means I have 2 long sides, which would be my length, so I could write this as 2L, and then I add my 2 shorter sides together, which would be width, so this is going to be 2L plus 2W is equal to, and it tells us the perimeter is 327 feet. So that is my first equation. My second equation, it says the length is 10 feet more than 3 times the width. So since it says the length is, I know that the length is equal to something. So in this case, it's 10 feet more than 3 times the width. So I'm going to start with 3 times the width, so 3W, and then 10 feet more than that. So more than implies addition, so we're going to add 10. And this is my system of equations. Looking at number 6, it says, what is the solution to the system? So the solution would be whatever the value x, y, and z are. So since we have x, y, and z, let's plug this into a matrix. So I have 3 equations. I'm going to have 1, 2, 3 rows, and I have 3 variables. So if I have a column for x, y, z, and then my solution, then my equals, I'm going to have 4 columns. So to fill this in, x is 2, y is -3, z is 1 equals -3. And then this one we don't have an x, so we're going to put a 0 right here since we don't have it. Coefficient of y is 4, z -2 equals -4. My last equation, I have neither x nor y, so this is going to be 0 and 0. Z will be 5, and then it equals 20. So now let's take this and plug it into our calculator. So same routine as last time. Second, x to the -1. Go over to math, we want option B. To put in my matrix, alpha zoom. This is a 3x4 just like last time, so we'll keep it as is. And then let's start typing in our numbers. So 2, nope, I forgot to delete. Oop, gotta make sure you go over to the next spot. -3, 1, -3, 0, 4, -2, and -4. Those are both zeros, 5, and 20. Let's hit solve. So in this case, remember, x, y, and z go in order x, y, z. So x is equal to -2, y is equal to 1, and z is equal to 4. That is my solution. So now moving down to number 7, it says, which is a solution to the system of linear inequalities? So one of these 4 points is a solution to this system. Now I'm going to go ahead and graph it onto this blank graph that is provided. Looking at my first equation, it's already in slope-intercept form, so I'm going to go ahead and graph this one as is. That plus 3 is my y-intercept, so 1, 2, 3. That is a positive 1x, so my slope is 1, so up 1 over 1. Up 1 over 1, do this a few times. To go the opposite direction, we do the opposite, so instead of up and right, we're going to go down and left. Now, since this is less than or equal to, that means I'm going to have a solid line. And then for shading, it says it has less than, so we want where y is smaller, which is going to be on the bottom side of this graph. Now let's graph our second equation. So this is x plus y is less than or equal to negative 1. I cannot graph this. This is not in slope-intercept form. So we need to subtract x over to the other side to fix that. And so then we get y is less than or equal to negative x minus 1. And this we can graph. That minus 1 is my y-intercept, so we're going to go down 1 right here. I have a negative x, so that is a slope of a negative 1. So that means instead of going up, we're going to go down 1, right 1. Down 1, right 1. I'm going to do this a few times. To go and do the opposite, to go the opposite direction. Up and left. And since this is also equal to, we're going to have a solid line. And this is also less than, so I want where y is smaller, which is on the bottom side of our graph. Now, remember, our solutions are only where our shading overlaps, and since these are both solid lines, we can include these regions of the line of our lines that border the overlap region. So starting with letter A, I have a negative 4, 2. So that means x is negative 4, 1, 2, 3, 4, and y is 2, up 2. So this point is over where we only have the red shading, so that means it does not work. Let's try B. B is positive 2, so right 2 and up 2 from my origin. That is in the purple only area, so again, not the overlap, so it doesn't work. C is 6, 1, so 1, 2, 3, 4, 5, 6 to the right, up 1. Again, only in the purple, it does not work. So lastly, we have letter D, that is 2, negative 3. So right 2, down 1, 2, 3. So that is on my line. So since this is a solid line, we can include it in our solutions, so D is our answer. Now lastly on this video, we have number 8. It wants the x value of the solution. So again, we're going to set up a matrix like last time. We have x, y, and z, so this will be 4 columns, 3 equations means 3 rows, so 3 by 4. So we're going to have 4, negative 2, 4, negative 16, 1, 2, negative 3, 9, 3, negative 1, negative 4, 3. And we only want the x value this time, so x, negative 1, going to RREF, alpha zoom, still a 3 by 4. Let's type in the numbers. Oh, my bad, guys. My apologies. Negative 16, 1, 2, 3, 9, 3, 1, negative 4, and 3. And so I have a value of x equals negative 1. Stay tuned for part 2 for questions 9 through 15.